Bismillahirrahmanirrahim. I thought I'd do an example of mean and standard deviation question. So here's one that I made up. So I'll first read it and then we'll try to do it, inshallah. So the question reads, over 500 kittens take an algebra exam. Now, what are kittens doing taking algebra exams? I don't know, but they are taking the algebra exam, and darn it, they're determined. So we have 500 kittens take an algebra exam. Okay, so the time for completion, and this does not include their like little potty breaks and getting some water or tissue or whatever. The time for completion follows a normal distribution. Okay, that's cool. And we are then asked calculate the mean. Okay, mean can be represented by various symbols, as we said before. You can use x bar mean, or you can use mu, or you can use mu like this. Those are symbols for mean. And so we're asked to calculate the mean and the standard deviation. Standard deviation like this, or you can use the lowercase sigma for standard deviation. Okay, so that's what we are asked to calculate, the mean and the standard deviation, given the information. Given the information below. Okay, a typo, excuse that. Now we're told the following information. We're only given two pieces of information, okay? Only 16% of kittens were able to finish exam in less than 4 hours, 15 minutes, and 30 seconds. Okay, and 97.5% of kittens needed at least 3 hours, 10 minutes, and 40 seconds. Okay, now how are we going to put it all together? Okay, the most important aspect of this type of questions is to understand the data, understand what is given to us. So what we're given to us is that we're told that 500 kittens take an algebra exam, and we're told that their times for completion, okay, follow a normal distribution. And this is very important because this tells us that we can use the empirical rule. And that's the 68, 95, 99.7% rule that we have learned previously. So it looks like this is going to be a normal distribution term type question. So we draw a hypothetical normal curve, okay? Okay, so here it is. So now the first thing we have to know what's on the x and the y-axis. In the x-axis is going to be the range of time. So range of completion, okay? Okay, so time, okay? That's what it's going to be. So the shortest time it takes for a kitten will be over here. So these will be like the bright kittens, like super smart Einstein kittens. And over here, the longest time it takes for the kittens, okay? So this axis is time, okay? And in the smack in the middle is going to be the average time it takes. Now, we are told that the time to completion follows this type of curve shape, right? So that's how we know it's going to be like this. So this is going to be the mean over here, okay? So that's going to be the mean. Now, to understand the information given, we kind of have to make like a pseudo graph over here. So let's do it. Remember, the way we did this is we kind of like cut off part of the graph over here, and we said 2.5% of the data falls over there. And then similarly, we cut off a little bit of the graph over here, this tail over here, and then we said 2.5% of the data falls over here. And the remaining, we did like something like this, if you remember, okay? And this was dividing the data into units of 1 standard deviation, like this, like 1, 1, like that, if you recall, right? And this is so that we can use the empirical rule, okay? Okay, so here it is then. And then we made these boxes. So what was left over, we divided them into right here like this, and then we made up a line like this. And we said this represents 50% of the data here to the left of the mean, right? And then we said this smaller box forms one standard deviation. The way it represents 68% of the data. And then we said two standard deviation represents 95% of the data. We didn't go three standard deviation. That I guess could be sufficient over here. Okay, so to understand the information given, you really have to master this graph, the normal distribution. So this is the mean, this is one standard deviation, this is another standard deviation from here to here. So this data point here would be the mean plus one standard deviation, and this data point here would be mean plus two standard deviation, okay? And this data point, I'm sorry, I didn't mean, let me use this mean plus one standard deviation, or you can use roll over there, and this is going to be mean plus two standard deviation, like this. And this data point over here is going to be mean minus one standard deviation over here, and this data point is going to be mean minus two standard deviation over here, this data point, okay, correspondingly. Okay, now then we said, then we had filled in the percentiles. Okay, percentiles went over here. So the first data point over there corresponds to 2.5 percentile. In other words, this data point right here corresponds to 2.5%, meaning 2.5 of the kittens took that much time, right, to complete this this test. Now, if this was 68%, remember we divided this up into 34% and 34%, and this ended up being 13.5% and 13.5% over there. This piece of data. In other words, okay, 68% of the data is contained in that part of the graph, okay, and then additional 13.5% of the data is in that part of the graph, okay. So now, so the 2.5% of kittens needed that time, and this data point over here, okay, that's 16% of the data from beyond over here, because 2.5 plus 13.5 gave us 16, and there was 16% of the kittens represented in this group over here, and this is of course 50%, and this data point was 84%. Okay, and this data point was 84 plus 13.5 is 97.5% of the data over here. Okay, so and this of course was the mean. All right. Now then we are ready to interpret the data that's given to us. Okay, we said 16% of the kittens were able to finish the exam in less than 4 hours, 50 minutes, and 25 seconds. Now, what that means is, okay, 16% of the kittens, which is right here, so they're giving us percentile, see, 16% of the kittens needed that much time. So this data point right there, okay, that corresponds to 4 hours, 50 minutes, and 25 seconds. That's how you write hours, minutes, and seconds. So, in other words, at this point, this data point, this time, that t represents a time where 16% of the kittens had completed. All the rest of them were still taking the test, a long time. Okay, and then this second data point over here, 97.5% of the kittens needed at least 3 hours, 10 minutes, and 40 seconds to complete the exam. Now this is a little tricky. Now when you hear these type of words, when you say at least, that particular terminology, when you hear word like at least this many, at least that many, then it's good to ask a counter question, okay, or a complementary question. in other words, if 97.5 is dead, what about the 2.5%? So what does that mean about the rest of the which is 2.5? So which means 2.5%, which is 100 minus 95%. So if 97.5% of the kittens needed at least that many, that means 2.5% of the kittens, okay, were able to finish in less than 3 hours, 10 minutes, and 40 seconds. So 2.5 of them needed just that much. So this corresponds to this data point over here. So that means this data point is 3 hours, 10 minutes, and 40 seconds. Okay, so this is the information that's given. So this value here corresponds to this data point, all right, and this value here corresponds to this data point over here. That's information that's given to us, okay? So the important thing here to appreciate is when you see a question like this, at least this many, at least that many, okay, sometimes it's helped to ask the complementary question. If 97.5 needed at least that much, that means 2.5% of the kittens were able to finish in that much amount of time, okay? The rest of them took longer. The rest of them were over here, okay? But 2.5% were able to do it in this way. Okay, now what? Okay, now what? Okay, now you have to appreciate something. Okay, you have to understand the values that were given were not random values. Okay, these were special values because they are values that correspond to one standard deviation. That's not the best color perhaps. They correspond to one standard deviation, and they correspond to 2 standard deviation from the mean. Okay, that way on that side, correct? So the values given they correspond. They're special values. Okay, so what we know is that, okay, so whatever the mean is, we don't know. That's what we're asked to find. We're asked to find the mean and standard deviation. The mean minus 1 standard deviation, mean minus 1 standard deviation, that's this value, it was equal to 4 hours, 50 minutes, and 25 seconds. And then we know mean minus 2 standard deviation, mean minus 2 standard deviation corresponded to that value, which was 3 hours, 10 minutes, and 40 seconds. Okay, now you observe that here we have 2 variables, x, okay, and 2 equations, 2 variables and 2 equations, and we should be able to solve that with reasonable ease, right? Elimination process or substitution process, okay? To do that, one of the other things that you need to be able to do in this question is to first change hours, minutes, and seconds to just hours, okay? So we're going to that's the first thing we're going to have to do. So 4 hours, 50 minutes, and 25 seconds, we're going to have to change all of that to hours, okay? So the way I do it, at least, is this, okay? This means this is 4 hours, okay, plus 50 minutes, okay, plus 25 seconds, okay? Right? Just write it out like that. So I change seconds to minutes first, okay? So how do we do that? Okay, so well, we know 25 seconds. How do we change that to minutes? Well, okay, 60 seconds is 1 minute. Okay, so this will give us the number of minutes, and that ends up being 0.4166 minutes. Okay, so you can rewrite this as 4 hours plus 50.4166, like that, minutes. Okay, now I change the minutes to hours. Okay, so this many minutes plus that many, so now I have 50.4166 minutes, how many hours is that? Well, 60 minutes is 1 hour. So you divide this by 60, then you get 0.840277 like that hours. I'm just carrying decimal. So this becomes 4.840277 hours. Okay, so this is how you convert hours, minutes, and seconds to hours. In the same way, then you have to convert 3 hours, 10 minutes, and 40 seconds into hours, okay? And if you do that, this ends up being 3.177 hours. Okay, so now we have both of these in terms of hours. So you can rewrite these equations as x minus 1 standard deviation equals 4.84. I'll just round it off to that, 4.84, and then mean minus 2 standard deviation equals 3.18. Okay, maybe I should carry more decimals, but I'm going to leave it at that. Okay, now solving this is not too difficult. What I personally would do is I would multiply this bottom equation by -1 like this, and then subtract them, so the x would disappear, and I would get 1 standard deviation to be equal to that minus this. Okay, and this ends up being 1.66, and this is hours. Okay, so standard deviation is 1.66 hours. Okay, and from this you can calculate the mean, because you can substitute it right here, I think. So mean minus 1.66 is going to equal to 4.84, and then you get the mean to be 6.5 hours. Okay, so, and there we have it. So the mean is 6.5 hours. Okay, so we want if the answer we want to be in the hours, minutes, and seconds, would be 6.5 hours. This time it turns out to be pretty easy. So this would be 6 hours and 30 minutes, and that's the average time it took for the poor kittens to do the exam. Okay, and standard deviation 1.66 hours. Okay, how do we convert that to hours and minutes and seconds? So this is 1 hour plus 0.66 0.66 hours, right? So here is 0.66 hours. Okay, so 1 hour is 60 minutes. So if you multiply that by 60 is 39.6 minutes. So this becomes 1 hour plus 39.6 minutes, which becomes 1 hour, 1 hour 39 minutes plus 0.6 minutes. Now it's converting that to seconds. Okay, so 0.6 minutes. Okay, 1 minute is 60 seconds, so you multiply 0.6, okay, by 60, you get 36. So this becomes 1 hour, 39 minutes, and 36 seconds. That's the standard deviation expressed as hours, minutes, and seconds. So there we have our answers. The mean, the average time it took for the kitten to do this algebra test, it was 6 hours 30 minutes, and the standard deviation was 1 hour 39 minutes and 36 seconds. So here is an example of mean and standard deviation. The key thing in this question, I believe, was to understand the data was given. 16% of kittens were able to finish in less than that. That meant that was this data point that was given to us. Okay, this is x value corresponding to this value. And this data point, 90%, was at 2 standard deviation this way. Once you appreciated that, that's another x value given for over here. And then the question thereafter becomes reasonable and not too difficult, I think. And all the kittens, I'm sure, did quite well. Until next time, as-salatu was-salam ala rasulillah. Assalamu alaikum.